An organic compound containing 40.1% carbon and 6.67% hydrogen as an empirical formula of dash. Solution. Before we proceed with the solution, I would like to remind you to subscribe to this channel if you are yet to do so, so as to be updated as soon as new videos have been released here. Thank you. Now, I'll be reading the question again. An organic compound containing 40.1% carbon and 6.67% hydrogen as an empirical formula of dash. Here we are asked to calculate the empirical formula of the organic compound. An organic compound is known to be a compound which comprises of carbon and hydrogen as the main constituents, with the presence of other elements such as oxygen, nitrogen, sulfur, and so on. Now, in this case, we have 40.1% carbon and 6.67% hydrogen as the elements given to be the constituents of the compound. And since it is being given in percentage, that is the composition, definitely the whole of the compound will be a composition of 100%. But if we add up the amount of carbon and hydrogen here, we'll notice it is not up to 100. Definitely there is another element present. And what's the element present? So in most cases where we have questions like this, the elements that will be left out is always virtually taken to be oxygen. Why? This is because it is the next most abundant element present in organic compound. So in organic compound, after carbon we have hydrogen, we have oxygen before we have the likes of nitrogen, sulfur, chlorine, and so on. So now we're taking the elements present in the compound to be carbon, hydrogen, and oxygen. We've been given the composition of carbon, we've been given the composition of hydrogen, but we do not know that of oxygen. So to get oxygen here, the first thing we'll do is to calculate the amount of oxygen present in the compound as well. I'll be doing that by saying, first let's note the amount of the elements present. We have carbon to be 40.1%, hydrogen to be 6.67%. Then for oxygen now, oxygen is unknown. So to get oxygen, since the whole of the compound is taken to be 100%, we'll be saying 100% minus the summation of the other two elements present. So we have 40.1% of carbon plus 6.67% of hydrogen. So this will be given 100% minus. Summing this, we have 46.77%, which is equivalent to 53.23%. This is the percentage composition of oxygen. For the question, we are being asked to find the empirical formula of the compound. Empirical formula is a formula which shows the exact number of atoms of elements present in a given compound. Simply put, we are to determine the number of atoms of carbon, number of atoms of hydrogen, and that of oxygen present in the compound. And to do that, we'll have to calculate the number of moles of each of the element present first, then we'll relate the ratio in which they combine. We can calculate this separately, but to save time we'll be doing it simultaneously. Hence we'll be having this in a tabular form. So we have carbon, we have hydrogen, and we have oxygen, that is the elements present in the compound. I'll have to increase the line. Okay. So now do not forget I said in getting the empirical formula we will have to calculate the number of moles of each of the elements. So now to get number of moles is always given as mass over molar mass. But in this case we'll be taking the molar mass to be the same thing as the atomic mass of the elements, the relative atomic mass. For the mass also will be taken to be a whole of 100 grams, since we have it to be 100%. So if the mass is taken to be 100 grams, definitely carbon will be 40.1 grams, hydrogen will be 6.67 grams, while oxygen will be 53.23 grams. So let's proceed. Avoid confusion, I will just put it here that percentage composition by mass. So for carbon, I have that to be 40.1. For hydrogen, 6.67. For oxygen, 53.23. Can have our unit here also to be in grams. Now the next thing is to state the relative atomic mass of each of the elements present. So I have the next row to be relative atomic mass. And my unit in grams per mole. So for carbon, carbon is 12, hydrogen is 1, while oxygen is 16. For our formulas for calculating moles, here I'll just say moles here I will have 40.1 divided by 12, 6.67 divided by 1, 53.23 divided by 16. And I have this to be, for carbon we have 3.34, for hydrogen we have 6.67, and for oxygen 3.33. So this isn't all yet, because we need to know the simplest ratio in which they can combine, and to know the simplest ratio in which they combine, we'll be dividing by the smallest of all of these. So and the smallest here now is 3.33. So we'll be dividing each of the number of moles of the elements by 3.33. So here I'll just say divide by the smallest. Dividing this, I have 1.0, 2.0, and 1.0. Now this will be the simplest ratio. Like I say, 1:2:1. So now this simplest ratio, the number we are having here now as the simplest number of moles here will then be serving as the exact number of atoms of each element present in the compound. The empirical formula of the compound will then be equal to C with the subscript of 1, but 1 will be insignificant here. So since it is one atom of carbon plus, so we'll just have C. For hydrogen now, H. Then the number of atoms we have to as my subscript. For oxygen, it is just 1 as well. So I have O here. So the empirical formula is CH2O, which should be serving as the final answer to the question. That will be all. Do not forget to subscribe and as well click on the notification bell so as to be notified as soon as new videos are being released. You can as well drop your comments in the comment section, like and share the video as well. Thank you.